Welcome back to Shark Games. If you're making a game, then you'll probably want the player to be able to interact with objects in the world. Maybe you want the player to be able to open doors, pick up items, press buttons, or activate machines. And the obvious way to do this will be to create a separate system for every single object that you want to be able to interact with. However, that very quickly becomes messy and very hard to maintain. A much better solution is to create a flexible interaction system where every interactable object works in its own unique way, but is still controlled by the same simple system. And the best part is that this is actually a lot easier than it might initially seem. The main concept we'll be using to create this interaction system is something called C# interfaces. Now, interfaces are one of those tools that might seem confusing at first. Once you actually understand them, they become very powerful and very useful. They can help you build more scalable code, can help you build reusable systems, can just help you clean things up. And not just in Unity, but in pretty much any programming context. So in this video, I'll show you guys what interfaces are and how you can use them to build a clean, very versatile, very powerful interaction system inside of Unity. Now, before we start building the actual interaction system, we first need to understand interfaces. Now, I highly recommend understanding this concept because interfaces are one of the most important tools that you can learn as a programmer. However, if you're only interested in the final system, then you can skip ahead using the chapters below. Now, what exactly is an interface? To understand, we first need to talk about abstraction. Abstraction is the idea of hiding unnecessary details, only showing parts of a class that other code actually needs to use. Now, I know that might sound very abstract. It's actually very simple to understand with an example. A simple example would be a car in the real world. When you drive a car, you don't need to know exactly how the engine works internally. You only need to know that pressing the gas button makes the car move forward. This means that the complex details of the system are hidden away, while a simple set of controls is exposed to the user. Programming works in a very similar way. An interface allows us to define a set of actions that a class must provide without worrying about how those actions are actually performed. A good way to think about an interface is as a contract or a promise. For example, imagine we create an interface called IInteractable. This interface can say, anything that implements me must have an interact method. The interface itself does not know what happens when interact is called. Instead, it only promises that this method exists. Every object that implements IInteractable can create its own unique version of that interaction. For example, a door can open, a health potion can heal the player, and an NPC can start a conversation. They are all completely different actions, but from the perspective of our interaction system, they are all the exact same. They are all simply objects that have an interact method. And this is what makes interfaces so powerful. Instead of creating separate code for every possible object, we can simply create one general system that works with anything that uses the same interface. And that is exactly what we are going to build today for our interaction system. So let's head into Unity and get started. Here I have a simple 3D Unity scene with the first-person controller from the standard assets and this really nice low-poly environment, both of which you can download for free from the Unity Asset Store, and I will leave a link to them in the description. Now, let's get started by heading into the scripts folder. If you don't have one yet, then go ahead and create it. Now, right-click, choose Create, Monobehavior Script, and we'll call it IInteractable. Even though we're about to turn this into an interface, creating the file as a monobehavior is simply the quickest way of generating files. Also, notice the I at the beginning of the name. Prefixing interfaces with an I is just standard C# naming convention, which makes it easier to separate interfaces from regular classes. Once that's created, open it up in your code editor. Since this script won't actually live on any game object, we can first clean it up a bit. I'll delete the start and update methods since we won't be needing those. Next, we'll remove the monobehavior inheritance since interfaces don't inherit from monobehavior. We also don't need anything from the Unity engine namespace, so we can remove that as well. Finally, we'll change this from public class IInteractable to a public interface IInteractable. And there you go, we now have an empty interface. Now we need to define what every interactable object should be able to do. In my case, I want every interactable object to be able to do two things. First, it should obviously be able to interact with the player. And second, I want it to provide a text that tells the player how they can interact with the object. For example, one object might need to display press E to open the door, and another object might need to display hold F to talk. Every object can have a completely different text, but our interaction system can retrieve it all in the exact same way. Now let's start with the interaction itself. We'll simply create a public void called interact. And that's the entire method. Notice that there isn't any code in this method, and as a matter of fact, there aren't even any curly brackets. That's because an interface doesn't implement functionality. It only makes promises about which methods exist. Every class that implements interactable will be required to create its own version of interact. A door might open, a chest might give you loot, and an NPC might start a conversation. They all respond differently, but from our interaction system's perspective, they're all just calling the same interact method. Next, we'll add a property for the interaction prompt. So let's create a public string called interaction text, and then we'll simply use curly brackets and say get. This is a C# property. You can think of it as a clean way of exposing a value. In this case, it exposes a text that our UI should display whenever the player looks at an interactable object. And that's all we need for our interface. We've now created a simple contract that every single interactable object in our game must follow. Now, let's create our first actual interactable object. Head back into Unity, right-click in the hierarchy and create a new object. You can make it anything you want. I'm just going to make it a cube. I'll place it somewhere in front of the player so we will be able to interact with it later. This will be our test object. Next, we'll go back into the scripts folder and create a new mono-behavior script called test interactable. Once you've created it, don't forget to add the script to the cube, otherwise the code won't run. Now let's open up the script. Just like before, we can clean things up a little bit. First, we'll delete the start and update methods since we won't be using either of them. Now it's time to make this class implement our interface. To do this, we'll simply go after mono-behavior and then add a comma followed by iInteractable, which means that we'll get a public class called testInteractable, which inherits from mono-behavior and implements iInteractable. And that's literally all it takes to implement an interface in C#. In fact, a class can actually implement multiple interfaces. If you ever add more interfaces to your project, you can simply keep adding them here, all of them separated by commas. You'll probably also notice that iInteractable has a red squiggly line underneath it. If you hover over it, then you can see that Visual Studio tells us exactly what's going wrong. It says that testInteractable doesn't implement the members required by the interface yet. Remember, the interface made a promise that every class implementing it will provide an interact method and an interaction text property. So now we need to actually implement both of them. First, we'll add the interact method. So let's do public void interact. Unlike in the interface, this time we do add a body to the method. This is where we define what should actually happen when the player interacts with this object. For now, we'll keep things very simple. Let's just say debug.log, and I'll just say interacted with Q. Now, whenever this interact is called, Unity will print a message to the console. Next, we need to implement the interaction text property. We'll first create the text that we actually want to display using a new variable. So let's create a serialized field private string, which I'll call interact text, and I'll set the default to e to interact. Using a serialized field lets us change the text directly from the inspector without having to make the variable public. Now we can implement the property itself. So let's create a public string interaction text. We will just say get, which will return the interact text. So this means that whenever another script requests interaction text, this property simply returns a string we just created. And with that, our first interactable object is finished. Let's head back into Unity. Make sure that the test interactable component is attached to the cube and then press play. You can now see that nothing happens. And that's actually exactly what we should expect. This is because we've successfully created an object that can be interacted with, but right now there's nothing telling it when to interact. So next up, we're going to build the player's interaction system to do exactly this. The way we're going to detect interactable objects is by using raycasts. You can think of a raycast as an invisible laser beam. We shoot it in the world and Unity tells us whether we hit something and if it did, exactly what it hit. So let's create a new mono-behavior script called player interaction and attach it to the player. If you're using the Unity starter assets like I am, you need to attach it to the player capsule object. Now before we continue, there's one small thing we need to do. The starter assets use Unity's new input system. But to keep this tutorial focused on interaction systems, I'm going to use the classic input API instead. If you're following along in a newer Unity version, you can go to Edit, Project Settings, Player, and then you can find the active input handling. We need to change this from Input System Package New and set it to both. Press apply when prompted and Unity will then restart. Now I must say that the new input system is definitely the recommended approach for new projects as it's much more powerful and flexible than the old input system, but explaining it properly deserves its own video, so for now using the classic input system lets us stay focused on the actual interaction system. Once Unity has restarted, well, let's open up the player interaction script. The first thing we'll do is create a few variables. I'll create a serialized field, private float called range, which I'll set as default to something like 5. Then we'll create a serialized field, private layer mask, which I'll just call layer mask. And then finally we'll create a private camera, which I'll call main camera. Now the range will determine how far away the player can interact with objects. You can obviously play around with this to find a good value. The layer mask tells our raycast which layers it should check for collisions. This isn't necessarily required, but it's a nice optimization because the raycast can ignore objects that we know we'll never interact with. Finally, we'll store a reference to the main camera, since that's where we will be shooting the ray from. We only need to find the camera once, so we'll do that inside of the start method. So inside of the private void start, we'll simply say main camera equals camera.main. And remember, start is only called once, right before the game begins. Next, let's create a new method called handle raycasting. So let's create a private void called handle raycasting. The first thing we need is a local variable to store information about whatever our ray actually hits. So let's create a raycast hit variable called hit. Now let's actually shoot the ray. So let's do if physics.raycast main camera.transform.position main camera.transform.forward out hit, with the range and our layer mask. We'll then actually negate this using an exclamation mark and then call return. This means that we are shooting the ray from the camera's position straight forward up to our interaction range. If the ray doesn't hit anything, there's nothing left to do, so we simply return immediately. That's why we put the exclamation mark here. Using these early returns keeps the code nice and flat instead of nesting everything inside of multiple if statements. Now that we know that we've actually hit something, we need to check whether it's actually an interactable object. Now instead of checking for a specific component, we'll check whether it implements our IInteractable interface. So I'll simply do if hit.collider.tryGetComponent, where we will take out IInteractable interactable. And then we will once again negate this using an exclamation mark, which means that if we didn't hit any collider which is interactable. If that's the case, so if we cannot interact with anything, then we'll simply set interaction text to be an empty string, and then we will once again return. So if the object doesn't implement IInteractable, we clear the interaction prompt and exit the method. But if it does, then we already know two things that are guaranteed to exist, because that's exactly what our interface promised. We know it has an interaction property, which means that we can say interaction text equals interactable.interaction text. And we also know that it has an interact method. So now we simply check whether the player pressed the right button. So we can say if input.getKeyDown, then we'll check for keycode.e. And then if we press this button down, then we will say interactable.interact. Notice how we don't care what the object actually is. It could be a door, a chest, an NPC, or our little test cube. As long as it implements IInteractable, the exact same code works without any changes. Finally, don't forget to call handle raycasting in the update method, because otherwise nothing will happen. And just like that, our interaction system is finished. Now let's head back into Unity. Make sure that the player interaction script is attached to the player. For now, I'll leave the interaction range at 5 and set the layer mask to default. Now let's create a simple interaction prompt. Let's right click in the hierarchy and create a TextMesh Pro text object. If Unity asks you to import the TMP essentials, you can go ahead and do that. On the canvas object, we can change the UI scale mode from constant pixel size to scale with screen size, and then enter your target resolution. I'm using 1600 by 900. We'll then position the text slightly below the center of the screen, center align it, and clear the default text. Finally, drag the TextMesh Pro component into the interaction text field on the player interaction script. And now we're ready to test it. When we walk up to the cube, the interaction prompt appears, and when we press E, our message is printed to the console. Our interaction system is now fully working. So far, our interaction system works, but interacting with a cube isn't exactly the most exciting thing in the world. So let's replace it with something a bit more interesting. I've removed the test cube and placed down this dungeon door instead. It's a free asset from Sketchfab, so if you'd like to use it yourself, you'll find another link to this in the description. I'll admit that it doesn't really match the environment, but I think it looks pretty cool. I've already created a simple open and close animation for the door. Now inside of the animator, I have two states, idle and open. There's also a boolean parameter called isOpened. The transition from idle to open happens when isOpened is true, and the transition back happens when it's false. I've also disabled exit time and set the transition duration to 0.25 seconds, so the door responds pretty much immediately when we interact with it. Now let's hook this up to the interaction system we just built. Since we no longer need the test object, I'll delete the test interactable script. Then I will create a new model behavior called door interactable and attach it to the door. One important thing to remember is that raycasts only detect colliders, so every interactable object needs one. Without a collider, our interaction system won't be able to find it. Now let's open up the script. Just like before, we'll first implement IInteractable. Then we'll create a few variables. Let's create a serialized field private string called openDoorText, which I'll set to e2openDoor. And then another serialized field private string called closeDoorText, which I'll set to e2closeDoor. And then finally, I'll set a serialized field private animator, which I'll just call animator. Then for the final variable, we'll say private bool called isOpened. The two strings are simply the prompts we'll display depending on whether the door is currently open or closed. We'll use the animator to control the animation, and isOpened keeps track of the current state. Let's start with the interaction text property. So let's create a public string interaction text, and here we'll do get, and then we'll do return, and then we'll say isOpened, question mark, close door text, else open door text. If you've never seen this syntax before, don't worry. This is called the ternary operator, and it's simply a shorter way of writing an if statement. We'll simply say if isOpened is true, then we return the closed door text, otherwise we return the open door text. The nice thing is that properties don't always have to return the same value. They can calculate what to return based on the current state of the object, which is exactly what we're doing here. Finally, let's implement the interact method. So let's go public void interact, where we'll first say isOpened equals negate isOpened, and then we'll say animator.setBool with the string isOpened, which will be set to isOpened. This means that the first line simply flips the boolean value, so if the door is closed, it becomes open, and if it's already open, it becomes closed. Then we pass that value straight to the animator, which plays the correct animation for us. Now let's save the script and head back into Unity. Make sure the component is attached to the door, that the door has a collider, and drag the animator component into the animator field in the inspector. Then let's press play. As we walk up to the door, you can see that the interaction prompt appears. If you then press E, the door opens. If we press it again, it closes again. And notice that the interaction prompt automatically updates depending on the door's current state. And we didn't have to change a single line of our player interaction code. And that's the real power of interfaces. Our player interaction script doesn't know or really care that it's interacting with a door. It simply knows that it's interacting with something that implements IInteractable. And that's it. We now have a clean, fully scalable interaction system that can work with basically anything in our game. Opening doors is of course just one example, but using this exact same interface, you could create all sorts of things. And once you understand interfaces, implementing new interactable objects becomes ridiculously easy. Just implement IInteractable, find what happens inside of interact, and the rest of the system already knows how to deal with it. If you enjoyed this tutorial or you learned something new, then I would really appreciate it if you left a like. And if you want to see more tutorials just like this, then be sure to subscribe to my channel so you don't miss any of them. Now thank you guys so much for watching, and I'll see you guys in the next one.